Most of the power supplies I kind of use for experiments are homemade, except this one isn't. This is a commercial unit. It's only a 1 kV supply by Bertrand. The nice thing about this is I also have the manual with all the circuit schematics. Well, not all of the circuit schematics, the high voltage parts are missing. But certainly from the point of repairing, this makes life a lot easier. So I just have a look inside it. It's not been opened in quite some time, so it would be worth it looking at. It's nice to get the layout idea in case you're trying to build anything like this. So with the lid off right away, what catches your eye is the size of this large transformer here. This is on the mains input side. That is quite a beefy transformer, but the supply is capable of producing a 225 milliamp output at 1 kV, which is quite a lot of energy. And the actual high voltage part is down here. This is a typical line output style ferrite transformer and a tripler here, and your output, your 1 kV output is available there. It's only about 50 volts on the smoothing on the low voltage side, and you've got your amplifier output drivers here and fan assisted cooling, which I'm not sure are absolutely necessary, but that is quite nicely made. The driver circuits is just on the plug-in, so you've got some old style analog op amps and the likes as part of the control circuitry here. Quite a noisy thing when switched on, you can see. But nice to control there, but that's already up at a kV. Takes a little while to discharge, but you can see it's dropping down. Okay, quick look from the underside perspective. What's interesting, I don't know if you can make out the thickness of the primary windings on this transformer, quite substantial. They're basically connected together, so there's a centre tap, and the actual supply wires are very thin in comparison, and also quite a long run. Just thought I'd let you see the inside of that. So while we're in the power supplies, I'd open up this one. This is my kind of partly homemade 30 kV supply. I use quite a lot. It's based around this Spellman module, which generates plus or minus 30 kV, but only at 500 microamps, so quite a low current. You can see this part's where the high voltage unit is totally potted into this kind of rubber or silicon rubber. This part is just your switch mode power supply for 24 volts DC, which is what drives the supply here. There's also 5 volts and 15 volts available here. I was thinking you can adjust the 5 volts up to about 6. I was thinking of just taking that to a plug outside, because that's a nice voltage for valve heaters or vacuum tube and CRT heaters. So it's always quite useful to have one power supply on instead of having a few. This is an addition here just for control for the voltage and the meter readouts, but fairly straightforward little power supply. So this is the reason I was looking at the two power supplies I had. I needed a supply that would generate something in the regions of 2 kV with enough current to go through a potential divider to drive this electron gun. This is a World War II radar tube, quite an old example, and I'm trying to drive it to check it out, and I ended up having to use the power supply on my Tesla coil, which is really based on a microwave oven. Not a very safe thing to do, but I can control it with the variac to give me the voltage to drive this tube. One other point, if you're setting these up, these only go up to 1 kV, so you need an old-fashioned AVO meter to look at voltages above that, as I have set up here. I can bring up the voltage here to, that's over 1K, or just around about 1K, that's 1.5, and you can see there's a a blue dot appeared on the CRT here. Early radar tubes actually used phosphors with a persistence. I'm not going to remove the potentiometers because of the voltage on them, but if I move this magnet around I can move the dot and it leaves a green trail, and yet the phosphor where it's struck is blue.